This review video on absolute extrema. Absolute extrema, they are extrema, so we are going to start by finding critical numbers. Critical numbers are where the first derivative is equal to 0 or where the first derivative is undefined. And then we are going to take those critical numbers and plug them into the original function. That should give us the y value of each of the critical numbers. We also need to check the endpoints of the interval. And then whatever's the biggest is going to be our absolute maximum. The smallest is the absolute minimum. So a basic example here, and then we'll take a look at one where it's shown up on the AP exam. So this asks for the absolute extrema of, there we go, of f of x equals 3x to the fourth minus 4x cubed on the interval from -1 to 2. So extrema, absolute extrema, could occur when the derivative is 0 or undefined. It could also occur at the endpoints of the interval. Those are the only places that absolute extrema could possibly occur. So we're going to take the derivative, set it equal to 0, solve for x. We're plugging those values, our critical numbers, into the original function. We also need to plug in the endpoints of the interval. What is that? 3 minus -4. And plugging in 2 gives me 16. So our absolute maximum value is 16, and our absolute minimum value is -1. This problem comes from the 2016 AP exam. It's on the no calculator part. It defines in the problem that g of x is equal to the integral from 2 to x of f of t dt. They give us a graph of f of x, and then we were asked to find the absolute minimum and absolute maximum value of g. So not of this graph, that'd be easy. We could just find the highest and lowest points, but the maximum and minimum of g. So maxes and mins occur when the derivative is 0 or undefined. So we need the derivative of g. Derivative of g of x would be equal to f of x. We want that to be 0. That occurs at x equals -2. X equals +2, x equals 6, and x equals 10. We need to check these points as well as the endpoints of the interval. We actually can rule out 2 and 10 here because prior to getting to 2, g prime of x, which is equal to f of x, is positive, and then it stays positive after 2. So if I go from positive to positive, that's not going to be the absolute maximum or the absolute minimum. And for the same reason, we can rule out 10. The derivative was negative and then stays negative, -0, stays negative, not a max or min, is not going to be the absolute maximum or minimum. So ruling out 2 and 10, we have not quite as many that we need to check. You can do it like I did on the previous example where we say g of -2, g of 6, and so on. A lot of times they make a chart instead. If you do make a chart, make sure you label what your chart represents. This is my x value and my g of x value. I need to make sure I have -2 and 6 on there. I also have to make sure that the endpoints of my interval are included. G of x is the integral from 2 to x of f of t dt. So if I plug in 6, I've got the integral from 2 to 6. Integral from 2 to 6, we've got a triangle, base is 4, height is 4, so area is 8. 2 to 12. So 2 to 12, that's 8. It's going to be negative 8. Base is 2. Height is 4. This is negative 4. So 2 to 12, 8 minus 4 is negative 4. Negative 2 would be the interval from, or the integral from 2 to negative 2. Don't like the bigger number being on the bottom, so I'm going to switch them, which I'm allowed to do as long as I also multiply by negative 1. So the integral from negative 2 to 2, that looks like 8 again. So negative 8. This one down here is negative 4. I'm going to do the same thing with the negative 4. So that was negative 4. So I'm switching them. Negative 4 to 2, but negative out front. Negative 4 to 2 is 4, so negative 4. So find the absolute minimum value. The absolute minimum is negative 8, and the absolute maximum value is positive